All right, properties of logarithms. The first property is called this. Number one is called the product rule. The product rule. So remember last semester you had something called the product rule for exponents? So that idea is the same when we talk about the properties for the product rule for logarithms. Now for exponents, remember for exponents, your product rule said this. If you have b to the m power times b to the n power, when you multiply like bases, what do you do with those exponents? You added them. So that would be b to the m plus n. Remember that? That was your product rule for exponents. The product rule for logarithms says this. The log of m times n base b. The log of m times n base b. So if you look at the product rule for exponents, what do you do with those exponents? I added them. So the log of a product, you're going to write, remember we said that logarithms are nothing more than exponents, remember that? So if you look at those exponents, what am I doing to those exponents? Adding them. So the log of a product, I'm going to write as an addition problem. So that's going to be the log of m base b plus the log of n base b. So that's the product rule. So the log of a product, I can write as what operation? Addition. Mistake people make is this. They forget about the base. You got to make sure that whatever base is there, you write the base in the sum as well. So if this was base 5, then you would say what here? Base 5. Okay? So don't forget about your bases. That's a very common thing that people forget to do is their base. They know they got to write as an addition problem, but they always forget about the base. So always connected to what you did last semester. Multiply like bases, you add exponents. So the log of a product, you're going to write as a what? An addition problem. Okay? All right, so let's do this example. Okay, so the directions will say something like use, the one you're finding is going to say expand. It's going to use the word expand. So use the, it'll just say expand. Expand the following logarithm. Okay, expand the following logarithm. All right, so for example, number 1. The log of 7 times 11 base 6. The log of 7 times 11 base 6. So I want you to expand it. So right now it's written as a product. I want you to write as a what operation? Addition. So what's the answer?
Log of base 6, 7.
Log of 7 base 6.
Plus log of 11 base 6.
Log of 11 base 6. And that's it. That's all you can do. There's your answer. So you expanded it. You went from a product to an addition problem. Okay, number 2. Okay, listen carefully. Listen. The log of 8 times 3 base 8. The log of 8 times 3 base 8. All right, so what are you going to write?
Log of 8 base 8 plus log of 3 base 8.
All right, so that's where we're at, right? Okay. Do any of you notice anything else you can do?
Add your arguments.
Say again? The 8 cancels out. What do you mean 8 cancels out? Okay, log 8 base 8 is what number? 1.
Oh.
That's just 1. Remember this right here? I'm going to go ahead and write it right here. Log of 8 base 8. 8 to what power is 8? 1. Oh. All right, right here, 8 to what power is 8? 1. So you need, this is where you might say, well, that's so easy that when we did the first one. But it gets a little bit complicated when you forget that you can simplify some stuff. So the log of 8 base 8 is what? 1. So that you're going to, now, is there a whole number that you can say 8 to what power is 3? No, so you leave it alone. So 1 plus log of 3 base 8. So the reason we didn't do it with the first one is because, think about it, the first log term. 6 to what power is 7? I mean, there is something, but is it a whole number, though? No. 6 to what power is 11? Is there a whole number that works? No. Okay. All right. Number 3. The log of 100x. The log of 100x. How do you expand it? First of all, expand it. How do you expand it?
Log of 100 base 10.
You don't even have to say base 10. You just say what?
Log of 100.
Log of 100. Because you're saying log of 100 already is understood to be what base? 10. So it's the log of 100 plus the log of x. All right? Now remember, this is multiple choice, right? So this is multiple choice, let's say. Would that be your answer? Would that be one of your choices? No. Why not? Because the log of 100, you know, is what number? 2. Log of 100 is 2. Remember, if there's no base, it's understood to be what? 10. So 10 to what number is 100? 2. All right? So what you really need to be thinking of is this. If the argument and the base are the same, or if, well, obviously you know there's going to be a 1. The arguments and the base are the same. So each time you want to think about what you did previously. So in your mind you're saying, all right, can I simplify this? 8 to what power is 8? 1. 10 to what power is 100? 10. I can't do anything with this because the argument is what number, what letter? X. All right, so you're done. Oh, I'm sorry. You got to write this as what, though? 2 plus log x. Okay? All right, now, let's look at this rule. Quotient rule. All right, quotient rule. So remember, and you dealt with quotient rule in Math 98, and you looked at it also in Math 99 with negative exponents. Math 98 were positive exponents. Math 98 was negative exponents. But the quotient rule looked like this. B to the m divided by b to the n. Remember, when you think of quotient, what operation comes into your mind? Division. Division. Think of product, what operation comes into your mind? Multiplication. So the quotient rule has to do with division. So if you remember, when you divide like bases in the last 2 semesters, what did you do those exponents? You subtracted them. So it was always the exponent of the numerator subtract the exponent of the denominator. So let's look at that in terms of logarithms. So the quotient rule for the logarithms will look like this. The log of m divided by n base b equal. All right, can you tell me what that equals? What do you think that equals? Very good. When we dealt with the exponent, she subtracted, right? Remember we said that logarithm is nothing more than exponent yesterday. Well, what am I doing to the exponents? Subtracting. So when you take the log of a quotient, you're going to turn into what operation? Subtraction. So it's the log of m base b minus the log of n base b. And then everything else is just like we did with the first three problems. So let's look at this one. So let's go ahead and expand. Okay, number 1. All right, let's suppose we had the log of 3, the log of base 3 of, let's say I want to do x divided by 27. How would you expand this?
Log of x base 3 minus the log of 27 base 3.
Good. So it'll be the log of x base 3 minus the log of 27 base 3. And then you ask yourself, can I simplify any of those terms?
Yes.
Yes. Based on what we did yesterday, you know that second one, you can ask yourself, 3 to what power is 27?
2.
3 to the
3
third power.
thirds.
Is 27. So the answer is going to be the log
X to base 3.
of x base 3 minus 3. Okay, number 2. The log of 8, the log base 8 of 23 divided by x. The log of 23 divided by x, base 8. So first of all, you're going to expand it using what operation?
Quotient.
What operation?
Subtraction.
Subtraction, because you're taking the log of a quotient. So you're going to say that's going to equal what?
Log of 23 base 8 minus log of x base 8.
Right. Can I do anything to any of those terms?
No.
So you're done. That's your answer. You can't say 8 to what whole number is 23. And then this one right here, the arguments of is a variable anyway. Okay. Number 3. Suppose we had this one. Suppose we had the natural log of e divided by 4. The natural log of e divided by 4. How are you going to write that first of all?
Natural log of e minus the natural log of 4.
Y'all agree? Very good. The natural log of e is what? 1. Because the ln is understood to have what base? E. So you'd say e to what power is e? 1. So that's 1. So it'll be 1 minus the natural log of 7. Okay? Oh, I'm sorry, 4. Yes. Yep. I don't know why I said 7. Number 4, the natural log of e to the 7th divided by 2. First of all, how are you going to write this? E to the 7 minus the natural log of 2. All right? Can I do anything else?
Yes.
Yes. What is the natural log of e to the 7th? It's just 7. Very good. Because remember how we did this. Even today, remember what we did? We said equal blank. What is this space right here understood to be? So we said e to the box equals the argument. What's the argument? Well, the base is the same, so therefore the exponents have to be the same. So box equals what? 7. So that's 7 minus the natural log of 2. It's not that difficult. You just have to know the properties. And I'll give you the properties on that formula sheet. Because there are 2 problems in your final dealing with these properties. All right. let's see, let's do this now. Okay, so remember, um, when you had x to the third power raised to the second power. What y'all do there? You multiply them, right? So when you have a power raised to a power, when you had a power raised to power, what do you do to those powers? You multiply them. So that would be x to the sixth power. Right? So that was called the power rule. That was called the power rule. So the power rule for exponents basically said that when you have a power raised to power, you just multiply the exponents. So let's see what it looks like in terms of logarithms. So it look like this for the power rule. All right, so listen carefully. You have the log of m raised to a power. The power is p. And let's say the base is b. So the log of m to the p power base b. Okay? All right, listen carefully to what you're going to do. You're going to rewrite this as, you see that power? You're going to put it out in front. So you're going to write it as a product. So you're going to say P times the log of m base b. So P times the log of m base b. So you take the power and you pull out in front. All right, now, something you need to be aware of. That m to the p is your argument. So p has to be part of the what? Argument. Okay? So I'm going to ask you this. You remember a while ago, I asked you, what's the log of 10 to the 8th power? And you did it the long way. You said, well, my base is 10, right? So I'm going to say 10 to box equal 10 to the 8th. What's the answer? 8. All right. Well, let's think about this rule now. This rule says I can take the exponent and do what to it? Pull out in front. So that will be 8 times the log of what? 10. Well, what is the log of 10? 1. So what's 8 times 1? 8. So the answer is just 8. So whenever you have the log of some argument raised to a power, you take, what can you do with that power? Pull out in front. Okay? So this is the rule you got to remember. So let's use it. Well, watch how you're going to use it. Okay, so you're going to expand again. Number 1, suppose I had the log of 6 to the 3rd power base 2. Log of 6 to the 3rd power base 2. So I'm going to expand it. So there's only one thing you can do to expand it. In other words, rewrite it in a different way. Move that exponent 3 and put it as a product. You put it out in front. So what's the answer?
3 log 6 base 2.
Yep. And is there any way I can simplify the log of 6 base 2? No. Because 2 to a whole number is not going to be 6. All right. Number 2, suppose I had this. All right, the natural log of the square root of x. The natural log of the square root of x. Now, you got to remember some things from previous courses and even things we talked about in here. The square root of x is going to get you. But how do you think you may want to rewrite the square root of x?
X to the 1/2.
X to the 1/2. So remember we talked about radicals yesterday and changing them to exponents. So the radical square root of x is x to what power? 1/2. So first of all, write this as the natural log of x to the 1/2, and now you can use the power rule. What's the answer?
1/2.
1/2
ln.
natural log of x. That's your answer. All right, now let's look at this one. The log of 4x to the 5th power. The log of 4x to the 5th power. Is that exponent 5 part of my argument?
Yes.
Yes. So what can I do with that 5?
Move to the front.
Put it in front. That's 5
5 log 4.
log of 4 times x, right? Or log 4x. But can I expand even further? Yes or no?
I'm not going to say a word. You're wrong.
Huh? Say it again? Product rule. Am I taking the log of a product? Guys, am I taking the log of a product?
Oh, here's that.
So can't I change it to an addition problem?
Yes.
Yes.
So
So that's going to be the log, so that's going to be 5 times the log of what?
4.
4 plus 5 times the log of x.
Yeah, I would have got date on that one. Not sure what.
But now you know, that you can do the power rule and then you can extend even further at times. So the product rule, yes.
With that option with, okay, like say we want to take our finals, we have the option to just take our final and use this off, like, you know how many doctors it is? I don't know.
Yeah, just let's not, because I need to finish this, okay? But if you ask me that question when we're done, because it really has nothing to do with this, your question. Okay. Number 4. The natural log of the cube root of x. You can write this as a natural log of what?
3 over 1.
X to the 1/3. So therefore, what's the answer?
1/3. We went at
ln x. Okay, number 5. Well, if you had this, log of x plus 4 squared. Log of x plus 4 squared.
2 x.
X plus 4. Now, here's a mistake people make. Don't confuse what you see here, that statement, the one I just wrote. Well, first of all, do you understand that you can take an exponent and write as a product, right? Okay, so you can take that power. So we're using the power rule. You're going to take that power, you're going to write as a product. Just like we did when we talked about a power is a power. What do I do with those powers? I multiply them. Here's the idea of product. So you're going to take that power and you're going to write as a product. Don't make the mistake and confuse this statement right here with this idea. What would you do here? You would just use a distributive property. So you'd say 7 times x plus 28, right? Students, not all of them, but there's always a handful that will distribute the log. LOG is not a number. It's a function. taking the log of something is a function. Just like f of 2, f of 3. Remember that that of does not mean to multiply. You're dealing with ideas of functions. So don't distribute. Do not, this is your answer, so don't make the mistake of saying this, 2 log x plus 2 log 4. That is not correct. Log is not a number, so don't do that distributive property. Okay? All right, now, let's see. Okay, let's look at this one. So there's only 3 properties. What are those properties called? Product rule, quotient rule, and power rule. There's only 3 properties. All right, now we're going to use them. Expand. Number 1. Log of x squared y cubed base 3.
Do you combine the 2 and 3 before you put it in front of the log?
What do you mean combine the 2 and the 3? I have no idea what you mean by that.
2 times 3 would be like 6 logs.
Okay, so he's saying, listen to what David said. Listen to what David said. He says, oh, I can go ahead and add those exponents. Who said that ain't right? Who said that ain't right? If you said that ain't right, you're correct, but tell me why.
Because your
Bases are not your bases are not the same. The only time you can add exponents is if the bases are the same. You got that? All right, bases are not the same. All right, so you cannot add those exponents. All right, very good. All right, now, what are you going to do? Product rule. You can do the product rule first. So using a product rule, so I'm using a product rule first. Product rule. So how do I write this using a product rule?
Log of x squared
Base 3,
plus log y
base 3. Now, look at what you have. Can I do anything else?
Move
Yes.
powers to the
I
front.
can use what rule?
Power.
Power rule. So therefore, I get 2 log x of, log of x base 3 plus 3 log of y base 3. Can I do anything else? No, you're done. Don't try and say, well, can I reduce those 3's? You could if it said 3 divided by 3, right? But is that saying 3 divided by 3? No, that's not a division. That 3 here is a subscript. That 3 is a base. So it's part of that log. It's part of this part right here, that log term. All right. Okay, so there's your answer. So remember, I went to go from here to here, I use what rule? And to go from here to use what rule? Power. All right. Let's look at this. Suppose I had the log of x cubed times the square root of y. Base, let's see base b. So the log of x cubed times the square root of y, base b. All right, what rule are you going to use first? Product rule. So that's going to become the log of x cubed base b plus the log of, now remember, square root of y, how you can write this?
Y to the 1/2.
1/2 base b. So product rule. And then I'll finally just use the what?
Power.
Power rule. So I get
3 log x base b
plus
1/2 log y
Yep. And I can't do anything else. That's all you can do. All right, number 3. Suppose they had this. The log of 36 x to the 4th power base 6. Log of 36 x to the 4th power base 6. What do you do first?
Product rule,
Product rule.
log of 36 base 6 plus log of x to the 4th base 6.
All right, so first thing you did was expanded using the product rule. Now what are you going to do?
Convert the log of 36 base 6 to 6.
Okay, so you have to recognize that log of 36 base 6 is just what? 2. And then you have to do what with this part right here? Use the power rule with this part. So that's going to be what?
4 log x to the base 6.
4 times the log of x base 6. Now, most of you will get to that point. Of those get to that point, there might be 1 or 2 of you that's going to say this: 2 plus 4 is 6. Can you do that? No, they're not like terms. It's kind of like saying in a previous course, it's kind of like saying 3 plus 5x is 8x. Is that true? No. Those are not like terms. Same thing here. So don't say 2 plus 4 is 6. So there's your answer. You're done. All right. All right, what about this one? Suppose you had the log of the cube root of x divided by 100.
Base, okay.
There's no base there, so this is to be a common logarithm.
Log of x 1/3.
Okay? So you're using what rule here?
Quotient rule.
Quotient rule. So go from here to here is a quotient rule.
Divided by,
Minus
minus,
log of
log of
100.
which can be converted into
So the first term, how are you going to write this?
1/3.
So I'm using what rule?
Power.
Power rule. So it'll be 1/3 log of x minus, and that you can simplify. What's that? 2. Okay. All right. So basically, all it is just using those 3 properties and some stuff you've learned before in terms of simplifying logarithms. What about number 5?
Is there going to be enough for this?
Suppose we had the natural log of e cubed divided by x. The natural log of e cubed divided by x.
So it's going to be
What were we going to use first? Quotient.
quotient
So you're going to say the natural log of
e
e to the
cubed
3rd minus the natural log of x. Now, most of you already know, listen to this, most of you already know from a previous lesson that that's just what right here? 3. If you want, so you can go directly and say that's 3. Because remember in a previous lesson we learned this. Ln is understood to have what base? E. That's understood to have base E. So e to the box equal e to the 3rd. So what's that box equal to? 3. But if you want to go ahead and use the power rule, that's fine. That's fine. So you'd say 3 natural log of e minus the natural log of x. But what's the natural log of e? No, don't say cancel. What's the natural log of e? 1. And what's 3 times 1?
3.
3. So it's 3 minus natural log of x. Okay? Let's see. All right, what if you had this? The natural log of 7 raised to the x power. What's that equal to? Don't make it complicated. What's that equal to? Guys, what's that equal to? The power rule. What's the answer?
Oh, XLM 7.
Why was...
Maybe the parentheses threw us.
Yeah, so I put the parentheses there just to let you know that this right here could be the same thing as just saying this. Oh, sorry. 7 to the x power. They mean the same thing. So don't let that parentheses that's there throw you off. Because we had a parentheses earlier, didn't we? Let me see if I can find it. We had one earlier, but that didn't throw you off then. Right here. Right? I had parentheses there. You told me what to do. You told me to use a product rule first, and I did. But then what you forgot to do was that you could expand it further. This one's even simpler, because that's just a 7 inside the parentheses. So make some connections between stuff you've had. All right, now, okay, so, all right, number 7. We're going to work on this one together. Log of x to the 8th power, y to the 3rd power, divided by z to the 5th, base b. Don't make it complicated.
Quotient rule first.
So there are several rules involved. In fact, is all the 3 rules being involved here?
Yes.
Yes, because you have a quotient. You also, in that numerator, have a what? A product. And then you have exponents, which involve the power rule. So you do the quotient rule first, though. And so how do I write this using a quotient rule? Log of the numerator.
X 8, Y 30.
Base b.
B
Minus.
log z to the 5th base b.
Yep. So that's where I'm at. Okay? Then, though, you can do something with that first law. What rule can you use that first law?
Product rule.
Product rule.
Log x to the 8th power.
Base b plus,
log y to the 3rd base b.
and then minus the log of z to the 5th base b. So I use the quotient rule first, and then I use the product rule with the first one. And now one more step when you're done. What's the next step? What
Gotta
rule?
use the power rule.
Power rule. So what's the answer?
So 8 log x base b plus 3 log y base b minus 5 log x base b.
Log z.
Base b.
And I can't simplify anything, so I'm done. Okay? I'm trying to give you some examples from these worksheets. All right, now what about this one? All right, so let's compare number 7. Let's compare number 7 with number 8. So here's number 8. All right, look at number 8. Log of x squared divided by yz. Log of x squared divided by yz. And the base, let's say, is 10. Okay, so in number 7, I use the quotient rule. Do I use the quotient rule in number 8?
Yes.
Yes. In number 7, I also use the product rule. Do you use the product rule with number 8?
Yes.
Yes. think about this. When I use a product rule, the product rule is that first logarithm.
Mhm.
Here, the product rule is going to involve which one?
Second.
The second one. So let's talk about that. Okay, so quotient rule first. What do I get?
Log of x
Squared minus the log of what?
y.
Y, z. Y'all agree with that part? What rule did I just use?
Quotient.
Quotient rule. Now I'm going to use what rule next?
Product.
Product rule with this one. Now you got to be careful. And what I'm about to say is very similar to when we solved equations. I am subtracting this, but this is really an addition problem. So when I subtract an addition problem, it's kind of like I'm doing what operation?
Adding.
Distributing.
Distributing.
Okay? So listen carefully. So I have, let me go ahead and use the power rule here. So that's 2 times log of x minus, and over here I'm put that in brackets just to kind of show you what I'm doing. So I'm gonna write this as what rule? Or what operation?
Product.
I'm using a product rule, so I'm gonna write it as what operation? Addition. So it's be log of y plus the log of what? Z. The problem though is that I'm subtracting both of these. So what would have caused some of you issues was this. You would have told me the answer would have been 2 log x minus log y plus log z. That's not correct. You got to distribute that negative through here. So what's the answer? 2 log x minus log y minus log z. Okay? All right, and then finally number 9. I think we have enough here. Number 9. ln of e divided by y raised to the 6th power. ln of e divided by y raised to the 6th power.
Power rule first.
Use a power rule first. So that's going to be what?
6 ln to that 2 or
E
over y.
divided by y. All right. Now, a while ago, we had one that instead of the quotient rule, it was the product rule. We go back. Let's see if I can find it. I can't find it. Okay, but anyway, so you're gonna write like this, and then now you're gonna use what rule?
The
Quotient rule, which involves what operation?
subtraction.
Subtraction. So what's the answer?
6 ln
E.
minus 6 ln y.
Very good. Am I done? No, because what else do you know? The natural log of E is what? 1.
So 6.
And 6 times 1 is 6. So what's the answer?
6 minus 6 ln y.
Yeah. Okay.